Hi all, welcome to the second part of the complete project workflow end-to-end in the machine learning. So we have done the lot of pre-processing and now it's time for feature scaling and the transformation. And what we mean by that is you have your multiple features in the data set and you want to transform them into different scale. It is not a good practice to have a multiple scale for your different attributes, and what the machine learning expect is to have a similar scale. And there are two ways to do that. One is the min max scaling, which is also known as the normalization. It's a simplest the compared to the other one. And what happens here in this, it's rescaled so that the ranging of your particular features which will be between 0 and 1, and there is a min max scaler from the learning to do that to that similar operation. Next one is the standardization, and the standardization is different, right? First it subtract the mean value, so the standardized value have a 0 mean, and then it's divide the result by the standard deviation. So unlike min-max scaling, standard does not restrict value to specific range like in the 0 to 1 or -1 to 1. However, standard is much less affected with by outliers. So for example, the district has the median income to equals to 100. And by mistake, instead of the usual 0 to 15 what we have in the data set, min-max scaling min-max scaling to the 0 1 range would map the outlier to 1, and that's wrong, right? So whereas there are whereas the standardization would not be much affected, and scikit provide the for standardization there is a standard scaler from the scikit-learning which do the standardization process. So if I run this, so min-max scaler is used for min-max scaling, and the standardization is standard scaler used for the standardization. Next is the what if you have your one of the attributes is the heavy tail. Heavy tail means on the right, it can be on the left hand side or the right hand side. And to give you example of it, let me show you the population attribute in the housing data. And as you can see, it's right rightly tailed. So most of the values are centered to this part, but the other section which is heavily right tailed, right? And if you convert into the log, you will see the Gaussian-like distribution, the bell curve, right? Next, you can also build your, instead of using the transformer from the scikit library, you can also build your custom transformer. So whatever we did here, right, nplog and show you the histogram. So same thing, you can also build log custom transformer by applying the population feature. So this is the first we need to import the function transformer, the function which we want to use nplog, inverse function np exponential, and this is the transformer, and we just have to use transform the attributes here, and it will produce the log pop. And we, if you visualize it, it's very much similar to what we have done using the nplog function. Similarly, you can build the standard scaler, right? And for this you can create your standard scaler clone class, and it has the definitions like this definition function. It's initializing for the class, then put and transform two methods. So likewise, the idea here is instead of using the already built, you can also build, if you want some different operation, you can build your own transformation. Let me talk about the transformation pipeline, which is important because there are scenarios, and this is heavily used in the production. So what is mean by the pipeline? So scikit-learn provide the pipeline class to help build a transformation steps, right? The sequence of the transformation. And here's the fun example. So we load pipeline class from these scikit-learn, and we say we provide in the pipeline, we provide the tuples, right? With two options, the input, this is a name, I want to impute the simple means all the missing value should have the median value. And also for standardization, we are going to use standardized scale. So it's create a pipeline means first execute this and second execute this. So if you don't want to name pipeline, you can just simply use the make pipeline the first and the second operation. So one and two like this. And in the name pipeline, you can transform all the housing numerical data, and this is what it's going to look like. Also, if you want to view it in the data frame, this is how it's going to look like. What is the numerical prepared? We are using this, convert into the data frame columns. The feature outs will give you all the columns, right? And indexing is again of the sorting num. And that's how the data frame looks like for the pipeline operation we just performed. And how to handle the numerical and categorical data. So if I go down, so there is a column transformer is there, which is very handy. Means if you don't want to do the operation separately for categorical or numerical, what you can do, you can use this column transformer, right? And in the column transformer, what the num attributes, these are all the attributes which have the numerical data set, right? And this one is the category. So you only have the one ocean proximity, right? And we can create two pipeline like category uh, numerical we already did, right? And num pipeline. So similarly, we can create categorical pipeline, make pipeline, do the same operation what we did earlier in the transformation, simple imputer strategy. Just update the most frequent if there are any missing value. A one hot coder is going to provide these metrics, and we can then use the column transformer for num means numerical pipeline on this attributes. Cat means categorical pipeline, and this so it's a tuple of three values here. So let me execute this one, no errors. And also better approach for this is the in the scikit-learn there is a import. You can do the import of make column selector and make column transformers. Again, you don't have to specify like we specify these are the numericals, like you have thousands of attributes, then it will be impossible for you to pick and choose. So best way is on the numeric pipeline, choose the column selector. So this particularly select your column based on if it is numerical, and based on this is object means the categorical, and it will do the same process. I would recommend to use this one. Num piping is not piping, it's pipeline. So instead of so we have a pre-processing completely done, and we can fit on the housing data now, and this is the data looks like. So by now you have yeah, we have done most of things. So we have the missing values in the numerical will be replaced by the medians, right? What we did. And in the categorical, if it is missing, then it will be replaced by the most frequent category here, this one, right? Also, uh, the categorical feature will be one hot encode. Most of the ML algorithm only accept the numerical inputs, and few ratio features will be computed and add. So bed ratio, room per house, people per house, that we have newly attribute we have created earlier. And the next one we have if feature with a long tail, it is replaced by the logarithmic, that also we done. And now all the numerical features are standardized, so as expected by the ML algorithms. So this the code that build the pipeline to do it will be very similar to this one, right? So we have ratio, we have a ratio column ratio, the ratio name, ratio pipeline, and this is the pipeline of make pipeline, this imputer for the median function for to make it logarithmic senders, right? And all the column choosers, and for pipeline on. So what this particular code does here, it's pre-processing on the column transformers. So this is a column, this is the function we want to apply, and these are the attributes in the data set, right? So after process, this is all the pre-processing, and we can run this. And if you want to see fit, right? And let's see the shape. So this is the shape. We have 24 features now, and if you want to see all the features name, this is what's going to look like. So these are all the after doing the pre-processing, these are all the features which we have done. And there's a lot of operation we did. We computed the median value, we converted the NP log, right? And for heavy-tailed attributes, we also did the pipeline based on the different attributes like bedroom, room per house. And so after this, we are completed with our pre-processing, and we have our data ready to to move the next step of selecting the and training the model. So let me, yeah, that's it for now, and I will see you in the next part, the final part.